I just want to, I would like to remind everyone not to interrupt our speaker while he is giving the presentation. If you have something to say, please just put it in the chat box to me or to Pam, and we'll get to it later. It may be just a question for us to answer. And then at the end of the Professor Bill's time, he'll be able to answer your questions. So I would appreciate if you did that. Take it away, Professor.
Okay, well, thank you so much and welcome. And of course, as always, Marie, if there are any difficulties, you will let me know. Seeing a video or something. Okay, so everyone, hello. Welcome to the first part of Women of the Stars. Now, for those of you who don't know me, my name is Dr. Bill THIERFELDER. I'm a retired professor of arts and humanities and currently a visiting docent at the American Museum of Natural History. And my work as a guide at the museum certainly contributed to my fascination with the remarkable women that we'll be looking at today. But I've always had a deep interest in astronomy. I grew up in the 1950s and 60s during the so-called golden age of space exploration. Thanks to my dad, I was a regular at the American Museum's Hayden Planetarium and its extraordinary Zeiss projector that absolutely made the sky, the stars just come to life. And it was my mom who took me to see the first run of one of my favorite films, Forbidden Planet, which 65 years later still remains a bit of catnip for my imagination. So let's begin. First off, there's absolutely no way that I can give more than a thumbnail sketch of these remarkable women in a 75-minute presentation. So if you want to do a deeper dive into their lives and contributions, please go to my website, makingwings.net, and take deeper dive number 36. So again, it's makingwings.net. Let's show you. Hopefully this will work. And there we are. So you should be seeing Making Wings there. And all I invite you to do is you go to the menu in the upper right corner. It's this little hamburger menu. You click on that. And among other things, you're going to see a whole grouping of deeper dives. For every presentation that I give at a library or an organization, I create a corresponding page on my website. So today's is number 36. You just click on the chevron and you go to 36. And what you will get is this. You'll get an introduction to the course, including, I also teach this as a 4-week course in person. Well, we're not doing that today. We're going to do the 2-part Zoom presentation. But whether it's 2 parts or 4 parts, I have suggested media. We'll talk about that in a bit. Printed as well as video resources. Some videos about the different astronomers that we'll be talking about this month and next month. And even a little sidebar about the world's oldest observatories. You're going to hear about a remarkable queen in Korea who built the first known observatory in the Eastern world. And we're going to talk more about that. And then I don't want to make you dizzy here, but I have pictures of some of these people, little biographies, additional resources. So you get the idea. You can really go down the rabbit hole pretty deep if you visit my website. Again, makingwings.net, deeper dive 36. Now, as you saw, I included a section, I should say, called recommended media, or suggested media. And I recommend James J. Watts's scholarly but very accessible biography of one of the early astronomers, Hypatia. She was from Alexandria in Egypt, and it's subtitled The Life and Legend of an Ancient Philosopher. Now, indeed, for the ancients, the study of math, astronomy, and the other sciences was a philosophical endeavor. David Sobel's best-selling The Glass Universe looks at the remarkable women of the Harvard Observatory of the late 1800s and early 20th century. And Mike Hoskins' book is generally regarded as the foremost expert on the lives of Carolyn Herschel and her brother William. His book is Discoverers of the Universe, and it explores the many ways their very close relationship helped to really change the face of astronomy. Now, meanwhile, Mariah Mitchell and the Sexing of Science, there's a title for you, is an excellent introduction to both the astronomer and the chauvinistic world of astronomy and the other sciences in the 19th century. George Johnson's wonderful biography, Miss Leavitt's Stars, delves into the life of Henrietta Leavitt, one of the women associated with the Harvard Observatory, which we're going to talk about a little later, and one of a group of women discussed in the previously recommended The Glass Universe. And if you enjoy theater, you might find reading the script of Lauren Gunderson's 2015 play about Leavitt really engaging. It's called Silent Sky, and I'll explain the title. Why is it Silent Sky? Well, I'll explain the title as we move along. So with all of these recommendations, let's dive in. Yes, despite many obstacles, each woman that we're looking at today, and in both presentations, has one thing in common, and that is persistence. When all the odds were stacked against them, and they often were, these women remained true to their goals and their visions. To paraphrase the late, great Joseph Campbell, they followed their bliss. Now, we're going to start with a look at 10 astronomers from the past. And again, these are thumbnail sketches. I encourage you to visit my website for much more detailed information, makingwings.net, deeper dive 36. But for today, we can say that the work of these 10 women became the foundation for the accomplishments of many astronomers who followed them, both men and women. Or in the words of a friend, upon these shoulders, modern women astronomers built their lives. And we begin with one of the earliest astronomers ever, male or female, the remarkable Enheduanna. Now, we know that she lived somewhere around 2350 BCE. That's at least 4,300 years ago. She lived in the Sumerian city-state of Ur, which is near the present-day city of Baghdad in Iraq. Now, I've indicated Sumer and Ur on the little map in the lower right of your screen with a yellow arrow. That's where she lived. Now, besides her achievement in astronomy, she holds the distinction of being the earliest poet whose name was recorded. Her father was the mighty king of that early civilization, King Sargon, and he appointed her to become the chief priestess in the temple devoted to the moon deity Inanna, seen in the carving at the bottom center of your screen. It was in that capacity as priestess that she was also made chief astronomer of the moon because of her remarkable ability to describe and predict lunar events, such as eclipses, as well as the location of stars in the night sky during particular seasons. Now, we should note at this point that much of ancient astronomy was actually closer to what we call astrology, seeing the stars, the planets, and moon as omens and guides, rather than purely celestial objects. Now, we don't know her actual birth name, but the priestesses in the moon goddess's temple called her Enheduanna, which translates roughly as ornament of heaven, most likely as a way of praising her position as King Sargon's child, but also as a way to acknowledge her astronomical and astrological gifts. Today, we recognize Enheduanna for her early contributions to stellar and lunar observations. Now, here we have some visuals. To the left, you see a Sumerian depiction of Enheduanna performing a ritual in the moon goddess's temple. By the way, the size of this little plaque that shows this procession is probably only about 7 or 8 inches across. It's quite small. And that is not unusual for this early civilization. In fact, in the middle, you see one of the clay tablets that contains a verifiable poem by Enheduanna. Sumerian clay tablets were often quite small, as I said, sometimes as little as 15 centimeters. That's about 6 inches. The cuneiform on it, made with metal or a wooden stylus, was often the size of 8 or 9-point font on your computer or typewriter. And finally, over on the right, you see the impressive crater on Mercury, the planet Mercury, named after her by the International Astronomical Union in 2015. They felt it was an honor that she deserved. Now, nearly 2,000 years after Enheduanna, we get Aglionike of Thessaly, the first known female astronomer in ancient Greece, known for her remarkable ability to predict when lunar eclipses would occur. Now, we think she was active between the 2nd and the 1st centuries BCE. The details are a bit unclear, as is the case with many aspects of Greek history that have been lost to the sands of time. We know of her thanks to writers like the Greek scholar Apollonius of Rhodes. And a full century after her death, she warranted mention in the biographical writings of the Roman historian and philosopher Plutarch. Now, according to some contemporary sources, she must have been a remarkable person because the male establishment was so abashed, perhaps even threatened by her acute prowess at predicting when lunar eclipses would occur, that they actually labeled her a sorceress. In fact, when she started a school of female astrologers, astronomers, they became known as the Witches of Thessaly, a group that may have lasted well into the 1st century of BCE, and maybe even further into the Common Era. The bottom line is that Aglionike was seen as a formidable figure with nearly supernatural abilities. In fact, there is even an ancient Greek proverb inspired by her powers of celestial observation. If someone asked whether a person could perform a particularly daunting task, the response would be, yes, as the moon obeys Aglionike. Now you can see in the photo on the right of your screen that over here, that Enheduanna, like Aglionike, excuse me, yes, that like Enheduanna, Aglionike had a crater named after her. You can see that crater there on the right. And hers is on the planet Venus. Writing in the 1st century of the Common Era, Plutarch writes that Aglionike was thoroughly acquainted with the periods of the moon, knowing when the moon was due to be taken over by shadows. Now, this is all quite remarkable when you think that Aglionike must have possessed the sophisticated mathematical and observational skills to predict lunar events. Now, today we know that a lunar eclipse, seen on the left of your screen, occurs on average only 2 or 3 times over a 3-year period. Partial eclipses, like the one seen on the right, can occur more frequently, but even they would require fine observational skills. Now, remember, Aglio-Nike did not have the advantage of star charts or computers or other modern devices. Now, our next astronomer is Hypatia, who lived in the 4th century of the Common Era in Alexandria, one of the great learning centers of the ancient world, and certainly most famous for its library, which at the time was the largest one in the entire Western world. The Romans clearly supported and encouraged her work as a philosopher, an astronomer, and a mathematician. She actually ended up being the head of the Academy of Alexandria, where she taught both philosophy and astronomy. One of her contemporaries, Socrates of Constantinople, wrote this of her: "There was a woman of Alexandria named Hypatia, who made such attainments in literature and science as to far surpass all the philosophers of her own time. Many came from a distance to receive her instruction. Because of the self-possession and ease of manner which she had acquired as the consequence of the cultivation of her mind, she frequently appeared in public in the presence of the magistrates. Neither did she feel abashed in going to an assembly of men, for all men, on account of her extraordinary dignity and virtue, admired her all the more." Unquote. Well, that's high praise coming from a man of the times, isn't it? So, as we've just heard, Hypatia became quite famous, and one of the things for which she became most noted were her star charts and her ability to predict the movement of celestial bodies in the night sky. Now, on the right of your screen, you see a constellation map. In her work as an astronomer, astrologist, we believe she was one of the first to actually create similar kinds of charts. Now, the chart seen on your screen here is obviously from a much later time, but it represents in a small way how Hypatia would have seen the stars, namely as mythological beings that paraded across the night sky. Now, all of that sounds wonderful, doesn't it? But sadly, her high regard was not held by everyone, and it was religion that precipitated her demise. Now, here's a little TED talk that fills you in. Now, you may have to adjust the sound on your devices, but here we go. All righty. All right.
In the city of Alexandria in 415 CE, the bishop and the governor were in a fight. It started with a disagreement over the behavior of a militia of monks and ended with an accusation of witchcraft leveled against one of the most powerful figures in the city. Hypatia of Alexandria was a prominent mathematician, philosopher, and advisor to the city's leaders. In the centuries since she lived, the details of her life have been the subject of much dispute and have taken on an almost mythical status. But while none of Hypatia's own writings survive, her contemporaries and students' accounts of her work and life paint a picture of the qualities that made her renowned as a scholar, beloved as a teacher, and ultimately led to her downfall. Hypatia was born around 355 in Alexandria, then part of the Egyptian province of the Eastern Roman Empire, and an intellectual center. Her father, Theon, was an accomplished Greek mathematician and astronomer. Her mother is unknown. Hypatia was likely an only child, and Theon educated her himself. By adulthood, she had surpassed her father in both mathematics and philosophy, becoming the city's foremost scholar and taking over his position at the head of the Platonic school, similar to a modern university. She refined scientific instruments, wrote math textbooks, and developed a more efficient method of long division. But perhaps her most significant contributions to intellectual life in Alexandria came through her teaching. The philosophy Hypatia taught drew from the legacy of Plato and Aristotle, as well as the mystical philosopher Plotinus and the mathematician Pythagoras. The convergence of these influences merged to form a school called Neoplatonism. For the Neoplatonists, mathematics had a spiritual aspect, divided among the 4 branches of arithmetic, geometry, astronomy, and music. These subjects were not studied merely for the sake of curiosity or practical utility, but because they authenticated the belief that numbers were the sacred language of the universe. In the repeated patterns of algebraic formulas and geometric shapes, the orbits of the planets, and the harmonious intervals of musical tones, the Neoplatonists saw a rational cosmic force at work. Students delved into this ordered mathematical world to achieve higher unity with this force, known as the One. While Hypatia was considered pagan, a term for traditional Roman belief before Christianity, she worshipped no particular deity or deities, and her ideas could be applied alongside multiple religious viewpoints. Jewish and Christian, as well as pagan students, traveled from the farthest reaches of the empire to study with her. The nonpartisan environment Hypatia fostered, where all students could feel comfortable, was especially remarkable given the religious and political turmoil that was fracturing the city of Alexandria at the time. Christianity had recently become the empire's state religion. The local Archbishop Cyril had steadily gained political power, commanding zealous militias of Christian monks to destroy pagan temples and harass the Jewish population. In doing so, he encroached on the secular authority of the Roman governor Orestes, himself a moderate Christian, leading to a bitter public feud between the two men. Because she was seen as a wise and impartial figure, Governor Orestes consulted Hypatia, who advised him to act with fairness and restraint. But when a group of Cyril's monks incited a riot, badly injuring Orestes in the process, he had their leader tortured to death. Cyril and his followers blamed Hypatia, accusing her of witchcraft to turn Orestes against Christianity. In March 415, as Hypatia was traveling through the city, the bishop's militia of monks dragged her from her carriage and brutally murdered and dismembered her. Hypatia's death was a turning point in the politics of Alexandria. In the wake of her murder, other philosophers in the Greek and Roman tradition fled, and the city's role as a center of learning declined. In a very real way, the spirit of inquisition, openness, and fairness she fostered died with her. For another harrowing tale of the demise of a powerful woman, watch our video on the ancient Roman Vestal Virgins and the...
Yes, the Vestal Virgins, that's another group. So let me just go here. And let me go here. So, wow, what a horrific end to an extraordinary woman. A woman who threatened the establishment. So while one branch of her society embraced her, another saw her as a devil who needed to be stopped. So like Aglionike before her, Hypatia was deemed a witch. And history, as you know, is full of talented women accused of being so-called witches who meet tragic ends. Of course, astronomy was not the sole province of the Western world. Our next astronomer is a Korean woman named Queen Seondeok, who ruled the kingdom of Silla in the 7th century CE. Her kingdom is marked in red on the map in the center of your screen. And you can see that Silla and these other provinces roughly correspond to what is South Korea today. Now, in addition to being only the second recorded female sovereign in Eastern Asia, she encouraged a renaissance in thought, literature, and the arts. She also has the distinction of creating the world's first known astronomical observatory. Now, as queen and a fervent supporter of the arts and humanities, it would have been quite natural for her to be interested in the movements of the stars and planets. Seondeok had 3 male partners or common law husbands, but she never officially married for political reasons. So much like Queen Elizabeth I of England, she remained married to her people. And here it is, still standing today. The Cheomseong, hello, Cheomseongdae. Okay, I have to say that fast 10 times. Cheomdaesongdae, the stargazing tower in Gyeongju, South Korea. The tower's location is noted on the map that you see on the left side of your screen. Now, as you can see from the nighttime photo, which is in the center, the tower is quite tall. You can see it in relation to the size of people standing at the base. It's over 3 stories. Sky observers would go to the platform at the very top to map the stars and planets. And from this humble beginning, thank you, Queen Seondeok, much larger observatories, both in the East and eventually the West, began to bloom across time. You may remember that I had on my website that list of ancient observatories. So there's a distinction between places, let's say like Stonehenge, which date back thousands of years, that where there were some observations made of the equinoxes and the stars and the heavens and so forth, as opposed to something like Cheomseongdae, where you actually have built an observatory specifically for this purpose of observing the stars. So there's a distinction there. So this is considered the first, if not one of the first, certainly in the East and perhaps in the world. Now, we now move forward several hundred years to the German-English astronomer, Caroline Herschel. Now, as you can see, she had a very long and fruitful life, nearly 100 years, spanning the 18th and the 19th century. She is considered the first modern female astronomer. She devoted her entire life to astronomy and never married. In her lifetime, she was recognized as the discoverer of several comets, including one that still bears her name, the Herschel-Rigollet comet, seen on the left of your screen. Now, when the French astronomer Roger Rigollet observed the comet in the late 1930s, he realized that it was the same one that Caroline had observed in 1788. And he wanted to make sure that her name was somehow affiliated with it in official astronomical annals. Hence the name Herschel-Rigollet comet. He did not want to take the full credit. He tipped the hat to Caroline. But here's the real focus of the story. Caroline was the younger sister of the famous astronomer William Herschel. Now, earlier in her life, before she really became fascinated with astronomy, earlier in her life and earlier in William's life, right, they were musicians. And in her case, she was regarded as a really highly talented female vocalist. She had a beautiful soprano voice. She performed regularly, most often with her brother William, who was usually playing the harpsichord or conducting an orchestra. Now, though they both enjoyed performing, William's growing interest in astronomy finally won the day, and Caroline, who was very much in the shadow of her brother, well, she dutifully followed. Now, during my research, I found this 18th century illustration that's now just put up on the right side of your screen. Now, note that her quote-unquote job seems to be that of a maid serving her brother tea while he polishes a mirror for his new telescope. She said somewhat bitterly in her autobiography, quote, "I did nothing for my brother but what a well-trained puppy dog would have done. That is to say, I did what he commended me, unquote. Yet, despite some bouts of bitterness, she too came to love astronomy and truly enjoyed her work. Yet the truth remains that she was often the behind-the-scenes astronomer who helped William achieve many of his successes. And one of those great successes was the discovery in 1781 of the planet Uranus, the first planet to be recognized since ancient times, and a celestial object that might have never been found without Caroline's computational and observational skills. Well, when the planet was universally recognized by the scientific community, King George III named William the king's astronomer in 1782 without even acknowledging Caroline. Well, in 1787, about 5 years later, after several petitions from Caroline herself and several others, including some of the other men astronomers in England, the king decided to give Caroline a small annual stipend, thus making her the first woman astronomer in England to receive a salary for her work in astronomy. Well, fortunately, there were men within the scientific community who were more forthcoming in recognizing her skills. And as a result, in 1828, she became the first woman to be awarded the gold medal of the Royal Astronomical Society. And in 1835, that same society made her an honorary member. Now, remember, it was still a men's-only organization. So the fact that they even gave her an honorary place, that was quite revolutionary. A similar honor came in 1838 when the Royal Irish Academy made her an honorary member. And thanks to her German heritage, the King of Prussia, Frederick William IV, presented her with the Gold Medal for Science on her 96th birthday in 1846. Well, now from here, four ancient astronomers and one 18th, early 19th century astronomer, we move towards the end of the 19th century and a remarkable group of American women. And let's begin with Maria Mitchell. Not only was she a stargazer, but she was also an early feminist, often speaking about the equality of women to the students she taught later in her life. In 1847, she discovered a comet that made her immediately famous, and we'll talk more of that in just a moment. But as a result of her discovery of that comet, she was the first woman to be elected to the American Academy of Arts and Sciences. She would remain the only woman to hold that honor until 1943. Like our previous astronomers, she made her work the primary focus and passion of her life, and she chose never to marry or have children. Now, I wanted you to see a comet similar in appearance to Miss Mitchell's comet, as it was called. It's a non-periodic comet, and that means that its orbital path may never cross through the inner solar system again, or it may take hundreds to thousands of years to return. So due to this, we actually know very little about the comet itself. Today, Miss Mitchell's comet is known by its less engaging scientific name, C/1847 T1. The discovery was initially credited to Francesco de Vico. Vico, observing from Rome, was the first to report the comet's discovery in Europe. However, Mitchell had observed the comet 2 days before Vico, so she became recognized as the comet's discoverer. Now, on the right of your screen, you see Mitchell in the 1880s, sitting by her telescope at Vassar College. These pictures of the comet and of Mitchell at Vassar bring up two things that I want to mention. And the first is the comet itself. Why was Miss Mitchell's comet, aka C/1847 T1, so important? Because it was the first telescopic comet found by an American astronomer. Telescopic comets are too distant, small, or faint to be seen by the naked eye. They can only be observed through a telescope, hence their names, telescopic comets. In 1848, King Frederick VI of Denmark awarded Mitchell with a gold medal for her discovery, something he had given to only a handful of male astronomers since the 1820s. Here was this 29-year-old American woman discovering something that few men had found. The Danish Award and the membership in the American Academy made Mitchell, certainly among scientists, an international name. But the second thing that I wanted to note is equally important, and that's her role as an educator. In 1865, despite being primarily self-taught and not possessing a college degree, Maria Mitchell became the first professor and the first woman professor actively recruited by and hired by Matthew Vassar to teach at his all-female college in Poughkeepsie, New York. She was also named director of the Vassar College Observatory, a position she held for more than 2 decades. And you can see that observatory on your screen. Further, Mitchell was also one of the editors of an astronomy column in Scientific American magazine during her professorship. And thanks to Mitchell's guidance, Vassar College enrolled more female students in math and astronomy than even Harvard University from 1865 until her retirement in 1888. But one fact that I really love to tell, and I put it in bold there on your screen, this thing that I love to tell about is that she demanded and she received the same salary as some of the male professors at the college. And trust me, even to this day, that is not the usual case. Now, as if that weren't enough, as a direct growth of her work as an educator, she was actively involved in the abolitionist movement prior to the Civil War, and later became a vocal supporter of the suffrage movement. She befriended various suffragettes like Elizabeth Cady Stanton, and after she returned from a trip to Europe in 1873, Mitchell helped to co-found the Association for the Advancement of Women, the AAW. In fact, she became its second president during the mid-1870s. Now, those are outstanding achievements when you remember that women like Aglianike and Hypatia were branded witches. And I'm sure women like Carolyn Herschel would have been both jealous and very, very proud. Now, there's the Maria Mitchell Observatory on Nantucket, the island Nantucket in Massachusetts. And what I'd like to do is to show you this lovely short video produced by the Knotgrass History Channel that fills in even more about the story of America's first female astronomer. Again, you may have to adjust the sound on your devices, and a small caveat, the closed captioning consistently misspells Maria's first name. Here.
Maria Mitchell observed her first solar eclipse with her father at age 12. As a teenager, she performed calculations to help whaling ships navigate on their long voyages. She discovered a comet when she was 29 and had a distinguished career as the first professional female astronomer in the United States. Maria Mitchell was born in 1818 on Nantucket Island. She was the third of 10 children. Maria's father, William, was a teacher and a scientific experimenter. He worked on chronometers, clocks that helped ships keep track of their longitude. Mariah's mother Lydia had been a librarian, and all of the Mitchell children were encouraged to learn and explore. Mariah also became a librarian at the Nantucket Athenaeum in 1836. During her many quiet hours at the library, she continued her self-education, studying Latin, German, physics, and advanced mathematics. The Athenaeum hosted public lectures by prominent people such as Ralph Waldo Emerson, Henry David Thoreau, Lucretia Mott, and Frederick Douglass. The Mitchell family had a telescope, which Mariah frequently used to explore the night sky. On October 1, 1847, she noticed an unusual object, which turned out to be a previously unknown comet. For her discovery, Mariah received a gold medal from the King of Denmark and was elected to the American Academy of Arts and Sciences, its first female member. In 1857, Mariah was able to fulfill a dream of traveling to Europe. During her time in England, France, and Italy, she visited with other astronomers, including John Herschel. John Herschel's father William and his aunt Caroline had also been astronomers. Caroline had been the first woman to discover a comet back in 1786. Herschel gave Mariah a page from his aunt's notebook of astronomical calculations. Since the 1840s, Mariah had also been working for the U.S. Coast Survey and Nautical Almanac as a computer. Until the mid-1900s, the term computer referred to a person who performed mathematical calculations. During the Civil War, Mariah continued this work. Also during the Civil War, Matthew Vassar was working to establish a college for women in Poughkeepsie, New York. It opened in 1865 as Vassar College. Mariah Mitchell was the first professor hired. She had insisted that the college build an observatory, and she lived there with her father until his death in 1869. Her mother Lydia had died in 1861. Mariah Mitchell believed in learning by doing. Besides regularly waking her students up to spend time in the Vassar Observatory, she led a group of students to Iowa in 1869 to observe a solar eclipse. She led another group to Colorado in 1878 to view an eclipse there. Here is her description of that event.
Our photographer begged us to keep our positions while he made a picture of us. The only value to the picture is the record that it preserves the parallelism of the 3 telescopes. As totality approached, all again took their positions. The corona, which is the glory seen around the sun, was visible at least 13 minutes before totality. Each of the party took a look at this, and then all was silent, only the count, on and on, of the young woman at the chronometer. When totality came, even that ceased. How still it was! As the last rays of sunlight disappeared, the corona burst out all around the sun, so intensely bright near the sun that the eye could scarcely bear it, extending less dazzlingly bright around the sun for the space of about half the sun's diameter, and in some directions sending off streamers for millions of miles.
Mariah Mitchell continued to teach at Vassar until illness forced her retirement in 1888. She died the next year and was buried on Nantucket Island. In 1902, her friends, family, and former students formed the Mariah Mitchell Association to celebrate her life and achievements. They created a museum in her childhood home and built an observatory next door. The association continues to provide science education for children and adults. Among various other tributes to Mariah Mitchell's long career as a scientist and educator, the comet she discovered is named after her, along with an asteroid and a lunar crater.
And I love that quote. We especially need imagination in science. It is not all mathematics nor all logic, but it is somewhat beauty and poetry. I love that. Okay, let's go back here and here. Now, you heard the word computer in there, right? Explained, that these were women who did calculations because there were no computers in our sense. Well, now we're going to meet a group of women who became, thanks to Edward Pickering, some of the most revolutionary astronomers and physicists of the late 19th and early 20th centuries. And they started out as computers. Now, we start with Williamina Fleming, who was born Williamina Stevens in Dundee, Scotland, and attended local schools until the age of 14, when she became a pupil teacher. In 1877, at the age of 20, she married James Fleming, and the couple emigrated to Boston, Massachusetts the following year. But her husband abandoned her when she fell pregnant with their son Edward, And in order to support herself and her baby, she took up a post as a housemaid in the household of Professor Edward Charles Pickering, who worked at the Harvard College Observatory. Well, as an aside, as I've already mentioned, I totally recommend Dava Sobel's book, The Glass Universe, which will give you much, much more of the rich background to this story, as well as the other women we're talking about for the rest of this program. Okay, so here is Williamina working as a maid. And it's Pickering's wife, Elizabeth, who recognized Williamina's, well, she had talents well beyond the custodial and maternal arts that she was using in their home. So much so that in 1879, Pickering hired Fleming to conduct part-time administrative work at the observatory. And it was there that Professor Pickering saw Williamina's true talents. The famous story goes that Pickering, becoming increasingly frustrated with the performance of the all-male mathematicians at the observatory, one day exclaimed loudly, "For God's sake, my Scottish maid could do better than you lot." And so, in 1881, Pickering hired Fleming to join the observatory officially as a computer, a person who would oversee and tabulate all the mathematical aspects of the astronomical data. Williamina became the first of nearly a dozen women computers, whom you see pictured on your screen, who would become the foundation for the observatory's work. Now, I'm sure many of Pickering's male colleagues found his choice daring and perhaps even traitorous or threatening to the male sex. In addition to her work as a mathematician, she became very interested under Pickering's tutelage in stellar spectra. Now, what does that exactly mean? Well, when you break down the light that a star emits, the way light breaks down into a rainbow of colors when sunlight passes through a prism, you are able to determine what elements make up that spectrum of light. Fleming devised a system for classifying stars according to the relative amount of hydrogen observed in their spectrum. Now, the chart on the right of your screen shows how different kinds of stars emit different amounts of the element hydrogen. Hydrogen appears as a thin, blackish line in the spectrum. Well, what Fleming recognized was that not all stars were alike, and that some were made of different amounts of basic elements like hydrogen. She was able to determine that these differences by exploring the spectra of stars, like the ones you see on your screen. So you see, the little lines of hydrogen here. Well, different stars will show, well, this has more helium, this is more sodium, magnesium, etc. Well, using her method, stars showing the most abundant levels of hydrogen were classified A. Those were hydrogen, where hydrogen was the second most, became B, and so on. Well, using this approach, Fleming cataloged over 10,300 stars for the 1890 publication of the Draper Catalog of Stellar Spectra, which was named after Henry Draper, who made the first spectral photograph in 1872. Her work became one of the foundations for stellar classification in the early 20th century. Now, another highlight of her career happened in 1888 when Fleming discovered the Horsehead Nebula on a photographic plate made by astronomer William Pickering, who was the brother of Edward. Now, at the time, professional publications neglected to give credit to Fleming for that discovery And the first edition of the Draper Star Catalog in 1890, which you just saw on the previous slide, completely omitted Fleming's name from the contribution list, attributing the entire work to Pickering. However, by the time the second catalog was published in 1908, Fleming and her female colleagues at the Harvard Observatory were sufficiently well known and received proper credit for their discoveries. Sadly, Fleming passed away from pneumonia in 1911 at the age of only 54. Now, needless to say, it was a deep shock to her colleagues and to the astronomical community. One of Wilhelmina's colleagues at the Harvard Observatory was Annie Jump Cannon, who lived well into the 20th century and who built on Fleming's work to develop a method of cataloging stars that is still used today. Now, unlike Fleming, Cannon was college educated, graduating as valedictorian from Wellesley College in Massachusetts, where she studied in the male-dominated field of physics, as well as astronomy. During the early 1890s, she also became an avid photographer. Cannon never married, but was happy to be the aunt to her brother's children. They became her family. Well, in 1893, after creating a photographic journal for the Columbian Exposition in Chicago, that's the same one where Nikola Tesla triumphed with his AC-powered motors and light bulbs, Cannon was stricken with scarlet fever. And that illness rendered her nearly completely deaf. But rather than become defeated, she dove into her studies once again. In order to gain access to a better telescope, Cannon enrolled at Radcliffe College as a special student, continuing her studies of astronomy. Radcliffe, seen on the lower right of your screen, was set up near Harvard College so that Harvard professors could repeat their lectures to the young Radcliffe women. This relationship gave Cannon access to the Harvard College Observatory. And as a result, in 1896, Edward Pickering hired her as his assistant at the observatory. Now, building on Fleming's work, Cannon, with Pickering, created the Harvard classification scheme, which was the first serious attempt to organize and classify stars based not only on their spectral types, but on their temperatures as well. You see, what Cannon realized was that the dominant color of a star had something to do with its temperature. O-type and B-type stars, for example, seen here on the left of the chart on your screen, which had greater amounts of hydrogen, tended to be brighter and hotter than predominantly dimmer and cooler red stars, which are over on the right of your screen. Now, of course, there were exceptions, but in general, even large red stars like the kind you see on the right side of this chart were cooler than the blue giants over on the left. Cannon's work showed that different elements, different colors, and different temperatures were all interconnected and provided a solid way to catalog stars. Pickering said that Miss Cannon is the only person in the world, man or woman, who can do this work so quickly and so accurately. Her work was honored around the world, and in 1921, she became one of the first women to receive an honorary doctorate from a European university when she was awarded a degree in math and astronomy from Groningen University in the Netherlands, which you can see on your screen. Now, like Maria Mitchell in the previous century, Annie Cannon also became very involved in the suffrage movement, participating in the massive 1913 March on Washington called a Woman's Suffrage Procession, see a picture in the background there on your screen. And in her professional life, Cannon helped women gain acceptance and respect within the scientific community. Her calm and hardworking attitude helped her gain respect throughout her lifetime and paved the path for future women astronomers. Now, as a final note, on May the 9th of 1922, the International Astronomical Union passed the resolution to formally adopt Cannon's stellar classification system. With only minor changes, it is still being used today for star classification. Now, here is a short video that explains the work that Cannon did and the accomplishments she achieved. Now, as you can see, it's a video that was created during the COVID pandemic when many of us had to rely on videos and face masks to continue our research. But still in all, I think it's a good little video. And again, you may have to adjust your sound.
History is full of the stories of amazing astronomers that have furthered our understanding of the universe. In the early 1900s, a group of women known as the Harvard Computers were working right here in Cambridge, Massachusetts, on a catalog of every star known in the night sky, an enormous undertaking. One of those astronomers, named Annie Jump Cannon, was particularly good at classifying those stars. She analyzed and classified over 350,000 during her career. So, how do we classify a star based on its light? Astronomers like Cannon looked for more clues hidden within starlight that can tell us more information than just how bright it is or what color it appears to be. Splitting starlight into the full rainbow of colors by attaching a prism or a grating to a telescope, they were able to identify the fingerprints of the elements that made up those stars. At extremely hot temperatures, each different element emits and absorbs light only at very specific places along the rainbow. Heat up neon gas, and it glows a distinct orange-red. Split that light up with a grating, and we can see the individual colors of light that combine to make that orange-red. Each element has its own pattern, so just like a fingerprint, we can use those patterns to determine which elements we're seeing. When we split up starlight and analyze its rainbow of colors, we can see dark gaps that correspond to those individual patterns from the elements that make it up. We can identify individual elements like hydrogen and helium by finding their patterns within a star's light. Annie Jump Cannon's classification method worked by looking at how strong or weak those patterns were in starlight. It ended up classifying stars based on their temperature. The hottest stars in the universe, O-type, glow blue at 50,000 degrees Fahrenheit on their surface. The coolest stars in the universe are red M-types, maybe only 4,000 degrees Fahrenheit. And right in the middle of that scale, our G-type star, the Sun. Classifying stars ended up being just the first step to understanding so much more about them, including star formation, life cycles, and even what causes them to shine. Annie Jump Cannon's classification system for stars is still used today. On the next clear night, go look up at the stars and see if you can spot the similarities and differences between them.
And that video was for the Museum of Science at Harvard in Cambridge. That's why he said during the presentation, right here in Cambridge. Quite a remarkable person. Now, another one of the great Harvard women, Antonia Maury, was also interested in star classification, especially the classification of binary stars, which I will talk about in a moment. She was born and raised in Cold Spring in upstate New York. Maury came from a well-educated family of theologians, geologists, paleontologists, and pioneering astronomers. She attended Vassar College, graduating in 1887 with honors in physics, astronomy, and philosophy. There, she studied under the tutelage of Maria Mitchell, whom we just discussed. Antonia Maury also never married and had no children. So Many of these scientists devoted their full career to astronomy. She came to work for Pickering at Harvard, and in 1897 published a catalog of stars and their chemical composition. Unfortunately, Pickering and Maury butted heads over their method of cataloging. So she actually left the observatory to teach at the Gilman School in Cambridge, Massachusetts. But after Pickering's retirement, Maury returned to the Harvard Observatory in 1918, where she had a fruitful relationship with Pickering's successor, Harlow Shapley. She remained active at the observatory until her retirement in 1948 at the precious age of 82, making landmark discoveries about binary star systems. Well, binary stars are just what the name implies, as the illustration on your screen shows. They are two stars, often very different from one another, that orbit each other. Now, in the depiction shown here, the red star isn't orbiting the blue one. Rather, they are orbiting each other, with the center of the orbital dance somewhere in the middle between the two. Maury was able to identify many of these systems and further able to analyze the chemical composition of the separate stars. Quite an achievement in the 1920s and 30s. Here's a little bit of fun trivia. The lunar crater, Maury, indicated by the red arrow, and several smaller ejecta craters, indicated by yellow arrows, are co-named for Antonia Maury and her cousin, Commander Matthew Maury of the United States Navy. To this day, they are the only lunar features co-shared by cousins. Now, there's a $1,000 Jeopardy question, if ever there was one. Well, the last of our early women astronomers and the last of our Harvard women was Henrietta Leavitt, who sadly passed away before her time from stomach cancer at the age of 53 in 1921 in Cambridge, Massachusetts. She was buried in the Cambridge cemetery near her mother, father, and her two siblings who had died in infancy. She herself, like everyone else today, chose not to marry, and she had no children. She graduated with honors from Radcliffe College in 1892. Thanks to her family, she had independent financial means, which meant she could work as a volunteer at the Harvard Observatory. Her work was so impressive, however, that in 1898, she was hired as the observatory's first curator of astronomical photography at the modest salary of 30 cents an hour. She became known for her work on variable stars, and we'll talk about those in a moment. Now, it was around this time, in the late 1890s, that Henrietta contracted an illness that left her, like Annie Cannon, largely deaf for the rest of her life. And that explains why the title of Lauren Gunderson's play about Leavitt, that I highly recommended earlier, is titled Silent Sky. Great little play. I hope you, if you can't see it, you pick up the script. It's really good, very engaging. Now, her colleague, Solon Bailey, would later write in Henrietta's obituary that despite her hearing loss, she had the happy, joyful faculty of appreciating all that was worthy and lovable in others, and was possessed of a nature so full of sunshine that to her, all of life became beautiful and full of meaning. Kind of reminds me of that phrase from Maria Mitchell, right? That there's so much poetry in science and in the world, right? Now, as a side note, one of the asteroids and two craters on the moon, pictured here, are named after her to honor deaf men and women who have worked as astronomers. But what I'd like to look at with you is Leavitt's contribution to the study of variable stars. A variable star is one whose brightness its magnitude, fluctuates. The change is caused by either the amount of light the star emits or by something partially blocking it. So what Leavitt realized was that there are really two kinds of variable stars. One kind of variable is called intrinsic variable. If you look at the pictures on your screen, you can see how the light from this star, moving from right to left, from left to right, I should say, seems to grow brighter over the course of about 6 weeks. This is because the star swells and shrinks on a regular basis. Leavitt discovered that some stars, called Cepheid variables, after a star in the constellation Cepheus, have very consistent levels of variation, making these variables a good measuring stick for determining astronomical distances. The physics involved in this calculation is quite advanced, and I won't even try to explain it here because, frankly, I find it a bit discombobulating myself. But the bottom line is that by being able to calculate the period of variation, and by knowing the speed of light, Leavitt was able to calculate the distance to that particular star. And astronomers today still use her basic formula. Now, the other kind of variable is the one that really grabs the attention of astronomers these days, and these are extrinsic variables. The magnitude or brightness of these stars changes because something is crossing in front of them, like a planet. Most of the exoplanets we know of today have been discovered through the study of extrinsic variables. These variables and exoplanets are truly some of the hottest topics in astronomy these days, no pun intended. Finally, Leavitt's work on Cepheid variables proved invaluable to her contemporary Edwin Hubble, who in the 1920s was able to use her ideas to determine the distances to galaxies, and thus was able to come to the realization that a university was expanding. Here's a short video from The SciShow, a YouTube channel hosted by Hank Green. It provides a really straightforward explanation of Leavitt's work. Here we go. Hank Green, cool guy. I like to show his work on many of my programs. Lots of energy.
How far away is the Andromeda Galaxy? What's the diameter of the Milky Way? How do we even know that the universe is expanding? These are questions that give me a headache, but we can answer them because we can measure the distance to stars. Astronomers do it all the time in a bunch of different ways, but we first learned how to do it only 100 years ago from a great mind who's as unrecognized now as she was in her own time, Henrietta Swan Leavitt. She was born in Massachusetts in 1868 and attended what would later be known as Radcliffe College, where she studied and excelled at astronomy. But after graduating in 1893, she couldn't turn her skill into a paying career, so she gave it away for free. She volunteered at Harvard College Observatory, working in an office full of women who were known as computers, catalogers who sorted, analyzed, and classified hundreds of thousands of photographs of the sky taken all over the world. It was tedious work, but for many women astronomers it was the only work available. Women couldn't direct their own research at the time, and they weren't even allowed to operate Harvard's telescopes. In fact, women were only allowed to serve as computers because the observatory couldn't find male scientists willing to do the work. So Harvard's computer office became a hothouse of some of America's greatest, if least known, astronomical minds. One of Leavitt's colleagues, for instance, was Annie Jump Cannon, who devised the spectral class system we still use to classify stars today. Leavitt, however, focused on stars in a cluster called the Small Magellanic Cloud. She was tasked with cataloging a class of stars known as Cepheid variables, stars that go through cycles of varying brightness over regular periods of time. Through her computing, Leavitt identified 2,400 new Cepheids, doubling the number known to science, but more importantly, in 1912, she made a discovery that would revolutionize astronomy. She found that the largest Cepheid stars in the cloud also had the longest periods of peak luminosity. The bigger they were, the longer they were at their brightest. The correlation was so precise that Leavitt could measure a star's size and immediately calculate its true luminosity. Now this was a huge deal because until then there was no way of knowing whether a dim-looking star was dim because it was just far away or because it was actually dim. But since the stars she studied were all about the same distance from Earth, she had discovered a kind of yardstick. You could pick a variable star anywhere in the sky, figure out its true luminosity using Leavitt's techniques, and use that to calculate its distance. This changed astronomy forever. Before Leavitt, astronomers could only measure stars about 100 light years away. Thanks to her discovery, what is now known as Leavitt's law was used to measure Cepheid stars millions of light years away. It helped settle the debate about whether other galaxies existed beyond our own, and it was ultimately used by Edwin Hubble to determine that the universe was expanding. Of course, Leavitt couldn't do any of this stuff herself because she wasn't allowed to touch the menfolk's telescopes, but Hubble later said that Leavitt deserved the Nobel Prize for her work, and he wasn't alone. In 1923, Swedish physicists asked the Harvard Observatory for Leavitt's research to nominate her for the Nobel Prize in Physics. But unfortunately, Leavitt had died of cancer 3 years earlier at the age of 53, and though women can get Nobel Prizes now, dead people cannot. That's just one of their rules. So thank you to Henrietta Leavitt and all the other human computers who didn't get space telescopes named after them for helping us understand how big and how awesome the universe is. Thank you for watching this episode of SciShow Great Minds. If you have other suggestions for great minds you would like us to cover in this series, please leave them in the comments below. We're also on Facebook and Twitter.
And you are really good, and the SciShow is just lots of fun. He is a bundle of energy, isn't he? Now, as we get close to wrapping up here, that little bit at the end is perhaps the saddest part of her story. Because she had died, she was never awarded the Nobel Prize that she so absolutely deserved to get, because there is, to this day, no such thing as a posthumous Nobel Prize. So there you have part one of our series. We'll do part two next month. These are a few of the astonishing women whose work became the bedrock for much of the astronomy that came after them. And certainly the work of the Harvard Observatory women, who all knew each other and worked together in what must have been a formidable work environment, forms the foundation for the 12 recent astronomers that we'll be looking at next month. Remember, you can dig deeper into these amazing ladies on my website, makingwings.net. Just go to Deeper Dive number 36. And I have videos for every single one of these people, with the exception of Aglianike. There's videos, there's lots of printed resources, so you could really, really go further into the rabbit hole. So now, as always, I like to say, it's time for your thoughts and ideas.